morning students. 12th physics. Magnetic effect of current. Continue. Questions. C. Find magnetic field at center O. You are given to figure out. Okay. Meaning of this is that these wires are up to very large distance. Yes. You have to find magnetic field at center. So first of all, as you are given this figure, we can divide this figure. It is made up of three parts. Like it is first part, it is second, and this one third. First part, okay, due to this wire, this wire is of infinite length. But see, point O is axial point, is on axis of first wire. Okay, point O is on axis of first wire. So magnetic field due to it will be 0. Simple. B1 is equal to 0. So due to this magnetic field is 0. Now for this second part. This second part is actually arc. Okay. Second part is actually arc. So due to arc, magnetic field at center, I will name it B2. B2 is equal to its equation, yes we know, mu 0 I theta upon 4 pi r. So is equal to, it is mu 0 I. So what is this angle? Yes, this angle is 3 pi by, so yes, it is 3 pi by 2, and in denominator it is 4 pi r. Simple. What is direction? So direction, how to find direction? See, current is going in this direction. So wrap fingers of right hand in this direction. So thumb is perpendicular to ball going inside. So inside means it is cross. Inside means it is cross. Simple. So it is magnetic field due to this. It is magnetic field due to this arc. Now magnetic field due to this wire. Now see, it is wire of infinite length. Yes, up to infinite length. And this point, see, this point is on its one end. Here it is. Here it is. So this wire is called semi-infinite wire. And see, for semi-infinite wire, what is equation? To see, for semi-infinite wire, what happens? Remember last lecture, for finite wire. For finite wire, you have to take actually two angles, theta 1 and theta 2. And yes, this end as it is here, so it will make angle 0. And this end as it is a large distance, it will make angle pi by 2. So for semi-infinite wire, you have to take theta 1 is equal to 0 and theta 2 is equal to, it is pi by 2 or 90. So what is magnetic field? B3 is equal to, it is mu 0 I upon 4 pi. What is distance? It is equal to radius. Here it is sine 0 plus sine 90. So for semi-infinite wire, you have to remember, okay, one angle is 0 and one angle is 90. Sine 0, that is 0, sine 90, that is 1. So is equal to, it is mu 0 I upon 4 pi r. What is direction? To see, here it is easy. Here how to define direction. Current is going in this direction. Point O is in upward direction. So wrap finger towards upward direction. Thumb is going inside. Yes, thumb is going inside. So inside means direction C. Okay. So B1 to 0, B2 and B3, they are in the same direction. So what is resultant magnetic field at point O? So therefore, resultant magnetic field at point O, resultant magnetic field at point O, B is equal to, it is B1 plus B2 plus B3, 0 plus, okay, what we can write directly, hello, chalo, we will write directly, mu 0 I upon 4 pi r, mu 0 I upon 4 pi r common, so it is mu 0 I upon 4 pi r common, here it is 3 pi by 2 and here it is 1, so it is your answer. Hello, yes, it is your answer. Clear? So yes, if you remember equations, then you can solve such questions easily, very easy. Okay. Next question. So what is next question? The distance at which the magnetic field on axis as compared to magnetic field at center of coil carrying current I and radius r is 1 by 8 would be. You have to find the distance at which means x is equal to question mark, where the magnetic field on axis, magnetic field on axis compared to magnetic field at center, compared to magnetic field at center is 1 by 8 is equal to 1 by 8. Magnetic field on axis compared to magnetic field at center is 1 by 8. So yes, you can write like this. Okay, magnetic field on axis is equal to 1 by 8 magnetic field at center. Chalo, equations. What is equation of magnetic field on axis of a ring? Yes, so it is mu 0 Ni a square upon 2 a square plus x square raised to 3 by 2. Yes, is equal to 1 by 8. Be center mu 0 Ni upon 2a, where a is radius. Yes, they are equal, radius are. I have written a for passive sequence. Okay. So chalo, mu 0 cut, n cut, I cut, then 2 cut, this 2 cut, and it out. Hello? And it out. Okay. Now I can write this 8 into 2 at this side. So it is 8 a cube. A square into a, so it is 8 a cube is equal to this side is a square plus x square raised to 3 by 2. A square plus x square raised to 3 by 2. So first of all we will take its cube root. Yes, we will take its cube root because it is 3. Okay, we have to actually find x. So we will take first of all cube root. So cube root. What is cube root of a? It is 2 root 2a is equal to, it is a square plus x square raised to 1 by 2. And now, okay. Now take square on one side. Yes, take square on one side. So it is 2 root 2. Sorry, what is square root of 8? 2 into 2 into 4. So it will be 2 only. Sorry, it is minus 10. Sorry, it is minus 10. Okay. So 2 into 2 is 4 and 4 into 2 is 8. So what is cube root of 8? It is 2. So it is 2a is equal to a square plus x square raised to this one. Now take square on both sides. So it is 4 a square is equal to a square plus x square. A square this side. Hello. A square this side. So it is 3 a square is equal to x square. So x is equal to, it is root 3a. X is equal to, it is root 3a. Or yes, if you are given radius r, then x is equal to, it is root 3. Yes, x is equal to, it is root 3. Clear? So yes, one simple question, we have to find value of x. Yes, you have to remember equations. Okay. So next question, let me check, okay, is it visible or not? Now next question, two wires of same length are shaped into a square and a circle. If they carry same current, then find ratio of magnetic moment. Magnetic moment. So first of all, yes, what is equation of magnetic moment? So magnetic moment, here I will write magnetic moment. Its equation is m is equal to n I a. N numbers of turns, I current, and a is area. Now what you are given, see, two wires of same length. Two wires of same length. Okay, that's its length is L, its length is L. Are shaped into a square. It is shaped into a square. It is shaped into a square, and another is shaped into circle. Okay, so chalo, if it is shaped into wire having length L is shaped into square, then what is length of each side? It is L by 4. Okay, and here if its radius is r, and here if its radius is r, then what is relation between radius and length? Yes, 2 pi r is equal to L. So R is equal to L upon 2 pi. What is area of square? A is equal to length into length, means it is L by 4 into L by 4, means it is L square by 16. Okay, here what is area? So area is equal to, it is pi r square. So it is pi, r square means L square upon 4 pi square. So 1 pi cut, 1 pi cut. So it's equal to L square upon 4 pi. Okay, so you have to find 2 wires of the ratio of the magnetic moment. Yes, ratio of the magnetic moment. So here I will say it is A1 and here it is A2. Here it is A1 and here it is A2. Then magnetic moment ratio M1 upon M2 is equal to M numbers of turns 1. Current I, what is area of this? It is L square upon 16 divided by, for M2, what is number of turns? 1. I this, and what is area? It is L square upon 4 pi. So I cut, L square cut, or it is 4, here it is 4, so this pi is to 4. So just M1 upon M2 is equal to, it is pi by, or you can say it is pi is to 4, simple. Okay, so yes, it is one question, it is simple question, okay, just you know how to solve this question and equations. Next questions now. Now next question, see, a thin ring of 10 centimeter radius. So write data, I is equal to 10 centimeter radius, carries uniformly charged, distributed on it. The ring rotates at a constant angular speed. Constant angular speed is omega. It is 40 pi radian per second. Above it axis perpendicular to its plane. If the magnetic field at center, is 3.8 into 10 raised to minus 9 Tesla, then what is charge on the ring? Q is equal to what? Yes, Q is equal to what? See how to solve this question. It is actually ring. Okay, from this you have to okay, magnetic field at center of ring. Magnetic field at center of ring. B. Its equation is mu 0 I upon 2r. Ring of radius. Oh, hello, it is r. Yes, it is r. So it is mu 0 I upon 2r. Chalo. B is given. Mu 0, that is mu 0, 2, that is 2r, that is I is not given. And you have to find Q. So first of all, you have to find what is the relation between Q and I. Yes, you know that. I is equal to Q upon T. Why? I am writing capital T because it is performing circular motion. So for that circular motion, you can write I is equal to Q upon T. Also, you know that omega is equal to 2 pi upon T. So yes, you can write T is equal to 2 pi upon omega. Okay, so I is equal to, it is Q upon T. T means it is 2 pi upon omega. So now in this equation, put value of I. That is B is equal to mu 0 upon 2r. And what is value of I? It is Q omega upon 2 pi. So now make Q as subject. Then if you make Q as subject, then 2 that is 4. So it is 4 pi r B divided by mu 0. Sorry, it is mu 0 omega. Yes, it is mu 0 omega. So it is simple question. Q is equal to 4 pi given R, given B, it is given, that is at center. Okay, yes, it is B. Okay, mu 0 that you know, and omega is also given, that is 40 pi radian per second. This is the question. Next one. An electron, a proton, and an alpha particle having same kinetic energy are moving in circular orbits of radius RE, RP, and R alpha in uniform magnetic field B. The relation between the radius. See, electron, proton, alpha particle have same kinetic are moving in circular orbits. Means for circular motion. for circular motion. We know what is equation of radius. R is equal to, it is mv upon q. R is equal to, it is mv upon q. You know what is relation between masses of electron, proton and alpha particle. You also know their charges. Magnetic field is common, but you have no idea, or no idea means not, you are not given data about V. Yes, you are not given data about V. You are given data about kinetic energy. The kinetic energy is same. Then we know some basic, okay, K half mv square is equal to K, and then so half m square v square is equal to mk. Then m square v square is equal to 2mk. Then mv is equal to under root 2mk. Simple. So yes, I can write this equation as R is equal to, here it is, under root 2mk upon mv. Now to constant mass for three particle mass different. K that is same for all. Q different. B same. So I can write R is proportional to under root m upon q. Yes. Now for electron, proton and alpha particle, how to write? To see, for Re is to Rp is to R alpha is equal to Re means I can write it is under root m upon what is charge of electron? It is E. And this is to Rp means under root mass of proton divided by what is charge of proton? It is, yes, is for alpha particle. What is mass of alpha particle? Mass of alpha particle, that is m alpha is equal to 4 times mass of particle, and charge of alpha particle, that is q of alpha particle, is 2. Alpha particle is basically nucleus of helium, and in nucleus of helium there are 4 protons, sorry, 2 protons and 2 neutrons, so 4 times mass, and 2 protons means its charge is 2. So yes, it is under root 4 mv upon 2e. So I can write this as this under root me upon e is 2, under root mp upon e is 2. 4, what is square root of 4? 2, and this 2 cancel out, so it is under root mp upon e. So see, Rp is to R alpha. The answer is same. Means one thing is clear. Again, radius of proton is equal to radius of alpha particle. Now, which one is greater and which one is smaller with respect to this? So we know one again relation here. Me is less than mp. Mass of electron 9.1 into 10 raised to minus 31. Yes, mass of electron 9.1 into 10 raised to minus 31 kg, while here it is 1.67 into 10 raised to minus 27 kg. So mass of electron is smaller, so this answer will be smaller and this answer will be larger. So we can say Rp is equal to R alpha is greater than it is Rp is greater than it is Rp. Okay, and yes, this question may be asked for different particles, for deuterium, for tritium, for Li plus, etc., etc., etc. You have to remember these relations. Okay, what is equation? R is equal to mp upon qb. How to write R is equal to under 2mk upon qb. Okay, so yes, it is one question. Okay.